Welcome to a new episode of the podcast. Fox Agent is made by AI for business executives that work with AI. Welcome to this deep dive. Today we're plunging into a topic that's not just fascinating, but increasingly critical for any business looking to truly leverage artificial intelligence, the central role of memory in AI agents. Think about it, an AI that actually remembers, learns, and builds on past interactions. We're going to pull out some really important ideas and, well, maybe some surprising facts about how this works and why it's such a game changer for your business decisions.
And that's exactly right. Optimizing AI agent memory isn't just some abstract technical detail anymore. It's rapidly becoming really a cornerstone of competitive advantage. Without robust memory management, AI agents can honestly fail. But with it, they empower executives with faster insights and smarter decision support than ever before. It's truly a make-or-break capability.
Okay, let's unpack this. Imagine Sarah, the CEO of a growing e-commerce company. Maybe she's frustrated because her chatbots keep asking customers for their order number 5 times in one chat, or suggesting products they just bought last week. That's a perfect example of an AI agent with no memory, or what we call stateless. So when we talk about AI agent memory, we mean the component that stores and recalls knowledge from past interactions, from data. It lets the AI remember context, facts, experiences, beyond just the immediate input. And we've come a long way from those repetitive bots. Now we have these modern memory-augmented systems that learn, maintain context, and can actually make coherent, informed decisions.
Yeah, and what's fascinating here is how we give these AIs different types of memory. It's sort of like our own brains. We usually talk about 2 main scopes,
Right.
Short-term and long-term. Short-term memory, or STM, holds recent stuff. Ephemeral information, like the last few messages in a conversation. It's crucial for immediate continuity, but it's limited, usually by the context window size of the language model.
Like how much it can keep in its head at once.
Exactly. Think of it like its immediate attention span. Older info can just drop off. That's why Sarah's old chatbot forgot everything. Long-term memory, LTM, on the other hand, is persistent. It's a store of knowledge available across multiple interactions, multiple tasks. This is what enables true learning over time, like an AI sales assistant recalling a client's preferences from months ago.
So it doesn't ask the same questions over and over.
Precisely. It avoids redundant questions, tailors recommendations. It's like having a digital veteran account manager. And a key technique for LTM is something called retrieval-augmented generation, or ARI.
RAG. Okay.
Yeah. In simple terms, RG lets the AI look up information outside its immediate brain, like checking a company manual, past sales records, and then use that retrieved info to give you a much richer, more informed answer. It basically extends the AI's brain.
So it's not just what it knows, but what it can look up. That does feel much more like human thinking.
Yeah.
We see parallels to how our brains work too, don't we? Like episodic memory, remembering specific events or experiences. An AI financial advisor might recall a user's past investment choices and, the outcomes.
Right, like that strategy worked for you last year on this type of stock?
Exactly. Then there's semantic memory. That's more generalized world knowledge, facts, concepts.
Things it just knows.
Yeah, like a legal AI recalling laws and precedents. It draws on this huge base of information. And finally, procedural memory, the knowing how. For AI, this is like learned policies or behaviors.
Like muscle memory for a machine.
Perfect analogy. Like a robotic process automation agent remembering the steps to fill out a web form. It doesn't have to figure it out every single time.
That's spot on. And this raises a really important question for business leaders. Why is optimizing this memory so critical? You often hear more data is always better, but with AI memory, well, it's a bit counterintuitive. Storing absolutely everything isn't feasible, and actually, it's not always desirable. Too much data can slow down responses, even confuse the AI.
So hoarding isn't the answer.
Not at all. As IBM's AI researchers pointed out, LLMs cannot, by themselves, remember things. And optimizing retrieval is key because too much data slows things down. Industry leaders are pretty clear. Agents fail without robust memory management. It's that fundamental. It's about smart storage, smart retrieval.
Okay, here's where it gets really interesting, I think. How do they actually build these memories technically? It's not just one big hard drive, right?
No, not at all. It's usually designed around 3 core pillars. First, the memory storage components themselves, where the info lives. Second, the retrieval mechanisms, how the AI finds what it needs. And third, crucially, integrating that retrieved information with the agent's decision-making modules so it can actually act on what it remembers.
Okay, makes sense. Storage, retrieval, action.
Exactly. Modern agents use a multi-layered hierarchy. Think speed versus capacity. At the fastest layer, like a CPU cache, is the working memory or short-term context, often just the prompt context for the LLM. It's what the AI is actively thinking about right now. But for long-term memory, the architecture usually involves external data stores. And this is where things like vector databases have become, well, incredibly popular.
Like Pinecone, Weaviate?
Yep, Pinecone, Weaviate, Redis with vector extensions. Think of embeddings as unique digital fingerprints for pieces of information. These databases allow super fast similarity search on those fingerprints. This whole vectorization of memory is really at the heart of modern AI memory.
So it can find related information quickly.
Very quickly, milliseconds, not minutes. And for structured data, like org charts or product relationships, you might also use knowledge graphs.
Okay, so the memory is stored, maybe vectorized. How does the agent find the specific piece it needs, the retrieval part?
Good question. The most common method is that similarity search we mentioned. The agent figures out what it needs, creates a fingerprint for that query, and finds the closest matches in the memory store.
But it's not just about similarity, is it?
No, you also have keyword and metadata searches, especially when specific fields matter, like searching a customer database for an order number. Microsoft's Copilot agents actually use a composite approach. They might search a CRM first, then broaden out to SharePoint if needed. They look wherever the data might be. And some systems even use the LLM itself to decide when to retrieve information and what to search for, like MemGPT. The AI basically asks itself, what else do I need to know here?
Okay, so it retrieves the info. Then what? How does that actually help the AI make a better decision or give a better answer?
Right, so once retrieved, that information is typically added to the large language model's input context. This is the core of our retrieval-augmented generation. The LLM's brain gets augmented with these external facts just before it generates a response.
Ah, okay, so it sees the user's question plus the relevant memories.
Exactly, and this whole process is usually managed by a memory controller module. It handles the queries, filters the results, puts the info in the right place. The architecture also handles updates. An agent might use a working memory scratch pad temporarily, or it might periodically summarize ongoing chats to save the key points for long-term storage.
So it doesn't get bogged down in every single word.
Precisely. Keep the essentials, discard the fluff.
And are there tools or frameworks that help developers build this? It sounds complex.
Oh, definitely. LangChain is a big one in the open source world for integrating different memory types. LangGraph helps build more complex, sort of hierarchical memory structures. And you see things like Redis being used as a high-speed buffer for recent interactions, keeping things really snappy.
Interesting.
And beyond what's common today, there's research pushing boundaries. Things like memory-augmented transformers that use special memory tokens.
Memory token.
Yeah, think of them like digital sticky notes embedded within the model's processing. They let the model carry key points forward across really long inputs without needing a huge context window. It's a way to give the model a kind of extended cognition.
Wow. Okay, so bringing it back to today, 2025, what does this look like in practice? What are the leading techniques and platforms businesses are actually using?
Well, right now, developers often use a mix of strategies. You see combination approaches, like a sliding context window combined with summarization. Keeps things manageable.
But summarization could lose details, right?
It can, that's the trade-off. So the more advanced approach, and really the de facto standard for enterprise applications, is retrieval-based memory, RAG, essentially. The system searches a knowledge base, maybe company documents, past tickets, product info, and pulls relevant bits into the context.
Like OpenAI's API allowing grounding data.
Exactly. Or Microsoft's Azure AI services integrating with enterprise data through their Copilot Retrieval API. Frameworks like LangChain and Llama Index make implementing this much easier too. You plug in a vector database as the LTM.
So you're basically giving the AI access to the company's collective brain.
That's a great way to put it.
What about the specialized tools, the vector databases, the frameworks?
Yeah.
What are the key players?
For vector databases, you've got Pinecone, Weaviate, Chroma, Redis, Elastic, all focused on speed and scale. Redis talks about microsecond-level read-writes, which is incredibly fast.
Wow.
On the framework side, besides LangChain, Microsoft has Autogen, which is interesting for multi-agent systems helping different AIs share memory. And academic projects like CoLA are defining memory types more formally. Then there are the LLMs themselves. Anthropic's Claude 2, with its massive 100,000 token context window, was a big deal.
Yeah, that could read a whole book, right?
Pretty much. A novel, a quarterly report. Anthropic suggested it can be substantially better than vector search for complex questions and really long documents because it just sees everything at once. OpenAI is also working on better attention mechanisms to stretch those context windows.
It's fascinating to think about multiple AIs working together.
Yeah.
You mentioned Autogen. How do different agents share knowledge? Is it like they have a shared mind?
Not quite a shared mind, but that's the goal. Coordinating shared knowledge is a huge frontier. Anthropic's research on societies of agents talked about sophisticated context handoffs and shared memory stores. The idea is often a common repository, like a shared blackboard where agents can read and write, lets them collaborate.
Or maybe one super smart agent.
That's the other approach, yeah. Like Cognition's powerful single agent maintaining its own continuous memory avoids the syncing headaches. But either way, everyone agrees that memory continuity, keeping context across long, complex tasks, is absolutely the make-or-break factor.
And what are some leading platforms where executives might actually see this advanced memory in action right now?
Well, you're seeing it integrated into major enterprise products. IBM watsonx connects LLMs to business knowledge. Salesforce Einstein GPT uses past customer data. Microsoft 365 Copilot is a big one. It uses Microsoft Graph to access your emails, documents, chats.
So it knows your context.
Exactly. It even builds a personal semantic index, basically a vector memory of your stuff to make search instant. And open source projects like Motorhead implement similar ideas, maybe using Redis for conversational memory.
So pulling this together,
Yeah.
what does this all mean for you, our listener, whether you're learning about AI or considering adopting it?
It means the core tech vector search, summarization, RIG, it's mature, it's out there, it's being used. Long-running agents with persistent memory, that's newer, but advancing incredibly fast. Really, any AI agent doing anything non-trivial today is expected to have some form of long-term memory. It's becoming standard.
So it's accessible now.
Yeah, through cloud services, open libraries. It's feasible to build agents that remember corporate knowledge and past interactions.
Yeah.
You don't necessarily need a giant research team anymore.
Okay, that leads perfectly to the big question. Why should our listeners really care about optimizing AI memory? What's the tangible value, the ROI?
The bottom line, the benefits are significant and often measurable. First, just faster decision-making. AI agents chew through data instantly. We've seen cases, like support tickets, with a 21% reduction in resolution times using memory-optimized agents. Think about Sarah's e-commerce support team.
Big difference.
Huge. Second, improved decision quality and consistency. Because the agent considers background knowledge, learn lessons, it avoids past mistakes. It offers more personalized interactions, more informed decision-making, and proactive optimization. That legal AI, it consistently cites the right case law because it remembers it.
Like having your best expert always available.
Exactly. Which leads to the third point, personalization and user satisfaction. An AI sales agent remembering preferences feels like talking to a veteran account manager, increases trust, makes things faster.
And the impact on internal efficiency.
Right, fourth, higher efficiency and cost savings. Studies show employees waste tons of time searching for info, maybe 70% spending unnecessary time.
Wow, 70%.
Yeah, AI agents cut that down. Gartner estimated that kind of inefficiency costs companies maybe $1.5 million annually. IBM found chatbots can handle up to 80% of routine stuff, scaling support by 40%.
That's serious savings.
And fifth, better decision auditability and learning. Agents can cite sources. Here's why I recommend this based on this report. That builds trust. Plus, the agent's memory becomes this evolving corporate knowledge asset. Helps train new people, spot recurring problems. It's like building an organizational brain.
What's fascinating here is comparing this to traditional approaches. It feels like more than just an incremental step up.
Oh, absolutely. It's a leap in both scale and adaptiveness compared to human memory limits or static software. A memory-enhanced AI learns from every interaction. It gets better as it works. That's compounding improvement. The more you use it, the more valuable it gets.
And are there numbers to back that up, like revenue impact?
There are. McKinsey found AI strategies, especially those using data-driven memory, like in marketing, can lead to 3-15% revenue uplift and 10-20% ROI increases on marketing spend. Smarter targeting, better decisions. It pays off.
Okay, let's ground this. Can you give us some specific, real-world examples? Where are businesses using these memory-augmented agents right now?
Sure. Loads of places. In finance and investment, you have AI portfolio managers recalling client history, autonomous trading agents remembering market patterns to react faster. JP Morgan's Koi-On platform uses semantic memory of regulations to review legal contracts way faster than humans could.
Impressive. What about healthcare?
In healthcare, AI clinical assistants brief doctors on patient history, pulling together relevant info. Radiology AIs remember tricky past cases to help diagnose new ones. Hospital management AIs might learn from past flu seasons to predict staffing needs for the next one.
That's incredibly proactive.
It is. In manufacturing, predictive maintenance is huge. Agents analyze sensor data, remember past failures, and say, uh-oh, machine #7, it looks like it did right before the gearbox failed last year.
Preventing costly downtime.
Exactly. MasterCard reported 70% fewer failures, 30% lower maintenance costs using AI. Supply chain forecasting also relies heavily on remembering historical demand patterns.
Okay. And customer service. Back to Sarah's e-commerce example.
Definitely. Customer service agents use session memory and long-term profiles. I see you called last week about X. That leads to that 21% faster resolution we mentioned. Zendesk highlights cross-channel consistency. The AI remembers you whether you call, email, or chat.
That consistency is key for customer experience.
Absolutely. Then marketing and sales. Agents monitor campaigns, recall past results. Last year's holiday campaign didn't work well for segment A. Let's try this. Tools like Triple Whale's Mobi analyze e-commerce marketing data daily to optimize spend. Salesforce Einstein uses memory for better lead qualification. Yep. Human resources. AI recruiting agents remember attributes of successful past hires to find better candidates. AI coaching agents track employee learning progress over time for personalized guidance. And broadly, across industries, think knowledge management. AI research assistants like Microsoft Copilot with SharePoint pull answers from the company's collective memory, saving all that search time.
So boiling it down, what does this shift really mean for our listeners?
It means memory transforms AI. It goes from being just a reactive tool, answer this question, do this task, to being a proactive, context-aware assistant or decision maker. Whether it's recalling a complaint or years of sensor data, that memory leads to quicker, more accurate, more insightful actions. It makes AI a genuinely intelligent partner.
Okay, the benefits are really clear. But realistically, implementing this advanced memory can't be completely smooth sailing. What are the main challenges or roadblocks businesses should anticipate?
No, it definitely has its hurdles. On the technical limitation side, even large context windows, like 100K tokens, aren't infinite. Information can still get missed, or the AI can lose focus over long interactions, attention drift.
So the window size isn't a silver bullet.
Not entirely. Context windows remain insufficient for extended sessions sometimes. Then there's retrieval accuracy. Semantic search is good, but not perfect. It might miss relevant stuff or pull in things that are only vaguely related. As one expert said, too much retrieved noise can confuse the model. Too little, missing key facts can lead to mistakes.
Finding that sweet spot.
Exactly. Updating memory continuously without constant retraining is also tricky. Avoiding outdated information. Scalability can be an issue too. Huge memory stores can slow things down or get expensive. And just the sheer complexity of managing memory, deciding what to keep, what to forget. You don't want a goldfish that forgets everything or a hoarder that remembers useless junk. This idea of strategic forgetting is actually quite important.
Right, intelligent forgetting. What about the practical side, getting this working in a real company?
Big challenges there too. Data integration and quality are often the first stumbling blocks. Enterprise data is messy, siloed, incompatible formats, sometimes just bad data.
Garbage in, garbage out.
Precisely. McKinsey points to fragmented data infrastructures or poor data governance as major hurdles. The AI's memory is only as good as the data it gets. You also need the right technical expertise. It takes a mix of skills, NLP, ML, data engineering, domain experts, IT plus ongoing maintenance. It's not set and forget. And there's always the latency versus thoroughness trade-off. How fast does it need to be versus how deeply does it need to search its memory, especially for real-time things like chatbots.
And then, of course, the ethical side. Storing all this memory, especially personal data, that must raise concerns.
Huge concerns. Privacy and data protection are paramount. GDPR, the right to be forgotten. How do you forget something embedded in a vector space? It requires strict access controls.
Like Microsoft Copilot respecting user permissions.
Exactly. Only showing you what you already have access to. Security is vital too. These memory stores are targets. Needs encryption, monitoring. And prompt injection is a risk tricking the AI via its memory.
What about transparency? Knowing why the AI decided something.
Critical. Transparency and explainability, especially in finance or healthcare. Triple Whale noted, transparency and explainability become increasingly important. Users need to trust it, regulators demand it. Being able to trace decisions back to memory sources is key. Then there's bias. If historical data is biased, the AI's memory can perpetuate that bias in hiring, lending, etc., or it might misuse sensitive
And
attributes.
the risk of the memory itself causing error.
Yeah, memory misuse or hallucinations. If the AI combines memories incorrectly or pulls something out of context, it can be really misleading, maybe even worse than a standard hallucination if it confidently cites a faulty memory.
So stepping back, how do these challenges hit the enterprise directly, beyond the tech?
Well, there's integration into workflow, just getting employees to trust and use these tools. Change management is huge, and maintenance and life cycle. The business changes needs evolve. The AI's memory and how it's used needs to adapt too. It's an ongoing commitment.
Okay, despite the challenges, the trend is clear. Looking ahead, say, the next 3 to 5 years, what's next for AI memory? What are the really exciting trends emerging?
We're expecting some big leaps. First, dramatically expanded memory capacities. Think much larger context windows, maybe even that 1 million token context becoming more common. Almost OS-like memory management for virtually unlimited conversation length.
Remembering everything from every interaction.
Potentially, yes.
Yeah.
Second, more human-like memory organization. Not just a big data dump, but hierarchical structures, dynamic indexing, better use of knowledge graphs for reasoning. A more organized AI brain.
That sounds much more powerful.
It would be. Third, continuous learning and self-improving memories. Agents that learn and refine their knowledge constantly without formal retraining. Lifelong learning, maybe even memory consolidation inspired by how humans sleep.
Wow, AI dreaming.
Maybe something like it. Fourth, enhanced explainability via memory traceability, making it easy to see exactly where the AI got its information, providing evidence dossiers. Crucial for trust. Fifth, hyper-personalization. Agents maintaining detailed memory per user or team, adapting deeply over time, like a truly personal assistant.
And how will multiple AIs play together in this future?
That's the sixth trend. Multi-agent ecosystems with shared memory. Swarms of specialized agents collaborating through shared knowledge pools, like Google's memory bank concept. Your marketing AI automatically shares insights with your sales AI.
Seamless collaboration.
That's the vision. Seventh, a continued focus on ethical memory management and privacy. Things like federated learning, better encryption, maybe even forgetfulness as a feature, becoming standard for sensitive data. And finally, all this enables new applications. Think AI project managers remembering every detail. Complex decision simulations where agents learn from virtual experience. AI acting as super researchers for knowledge discovery, finding connections we missed.
So, bringing it home for our listeners, what's the takeaway from looking at this future?
It suggests memory optimization will become even more central, maybe even a commodity. This allows AI to tackle much more complex, nuanced decisions. Areas like strategic planning, holistic customer experience. AI will become an even more capable partner, moving from just doing tasks to being a strategic collaborator because it can remember, synthesize, and learn from vast amounts of context.
Okay, so to recap our deep dive today, AI agent memory optimization is fundamentally changing the game. It's transforming AI from simple bots into intelligent, reliable assistants, even autonomous decision makers. And this is directly improving decision speed, quality, and consistency, offering a real competitive edge.
Absolutely. Robust memory really tackles that old Achilles heel of AI, the lack of context, of continuity. This evolution towards memory-augmented systems is what makes modern AI agents truly intelligent and adaptive. They can support entire processes, learn, and grow with your business.
And the implications here feel profound. It goes beyond just efficiency. It hints at AI systems that could genuinely contribute knowledge back to us, uncover hidden insights in our data, ensure critical information informs every single decision, making the whole organization smarter and more adaptive. Thank you for joining the podcast, and see you soon.